In lecture 11, we are going to study photochemical. There is photochemical reactions and also charge transfer processes and so on. So the first, in the previous lectures, I only mentioned the one type of the photochemical reactions, which is called initial process, meaning the reaction starts from the excited states, like S-singlet or triplet excited states. But this is one type of the reaction. And in general, there are two types of photochemical reactions. The other one is called a secondary process, which is induced by active species like radicals, ions, and so on, and which are generated by the light irradiation. Okay. So the initial processes, the reactions are quick on the order of, for example, nanosecond, microsecond order. However, in the secondary processes, it's really depends on the chemical species, and sometimes it takes much longer time. Okay. So at first, here I will show one of the well-known example here, which is for the reduction reaction of benzophenone. And because this reaction itself was found very long time ago, and it is well known in the field of photochemistry, and also because this reaction includes the initial process, both initial process and the secondary processes in the single reaction process. So that's why it is often raised as an example. So at first, I will show the total process of reaction, which is it's a pH indicator, of course, benzene aromatic ring. And so this one is benzophenone, which is one of the key players in photochemical reactions, and it includes the carbonyl. So, and it's after excitation, it's the very high inter-system crossing induced the most of the excited states changing into the triplets. So those one react with acetone. And then after several reaction processes, actually changing into like this. So then pinnacle, and also oh, I'm sorry, this mistake. It's to secondary propanol, and then it's changed to the acetone. So it looks like just a simple so oxidation of secondary propanol, and then the reduction of the benzophenone, and they dimerized into the single molecule. So looking into the initial process of this reaction is, so initially initial light is absorbed, and in pi2 excitation. And pi star excitation. But due to the very high inter-system crossing ratio, within a very small short time, 1 over a picosecond, let's change it into a triplet state. Okay. And then this molecule is easily capture the hydrogen from the proton. And this one taken, and then the benzophenone become radical species, and also the propanol also become the radical species. And this is propyl radical, and which has a very strong reducing ability. And then this one. So in the secondary process is due to these radical species, the reaction proceeds. And what happens here is the unreacted, the benzophenone is reacting with this radical species. Now, since this one has a very strong reducing ability, it gives this hydrogen species, and which makes another radical species or from the benzophenone, and then this the propyl radical is changed into acetone, right? And finally, due to these two formed radical species coupled to dimerization, so and then that makes benzophenol. The name is like this. So this is what happened in a process. So as you see in this total reaction, as an initial process after photo excitation and an N-pi excited state was reacting with another molecule, and then after formation of radical species, these radical species react with other chemicals. Okay. So And then now move on to some of the typical photochemical reactions. First, let's see the reaction due to the carbonyl species, which I've already mentioned in an example. So there are two types of the typical photochemical reactions in carbonyl. Here's the things. The first thing is, and then they are called Norris type 1 and Norris type 2 reaction. In Norris type 1 reaction, it's like this. So since the carbonyl is due to the n-pi star excitation, since one of the electrons are excited to the pi star reaction, then so this one is excited to pi star, right? And then this radical-like species and affect the one of the bond between the carbon and other atoms. So this is alpha carbon. The bond dissociation of alpha carbon happened in Norris type 1 reaction. And the other reaction is called the Norris type 2 reaction, which is if you have a carbonyl again due to n-pi star excitation. This one is something like CO radical-like species. And then if you have this molecule find a hydrogen nearby, it's taken to here. So hydrogen obstruction reaction happened. Okay. So these are the typical the reactions of carbonyl. And not only this, there are many photochemical active species during the photochemical reactions. Like in many cases, the big difference from the general synthetic chemistry and the photochemical reactions are the radical species. Since radical species, you cannot predict easily that radical has a reducing ability of oxidation ability. So it's a bit difficult to estimate what kind of reactions happened for each radical species. Okay, and the thing is, during the photochemical reaction, active species formed by bond cleavage, in a sense, for example, here, dissociation reaction, alkyl halogen molecule is the bond is cut off to generate two type of the radical species. And also Norris type 1 reaction, if you have a carbonyl with two alkyl chain, you can observe the alkyl radical and also the carbonyl radical. And also Norris type 2, it's a hydrogen obstruction reaction, and also that one also gives a radical species. Okay. And here's the thing, the radical species, as I already mentioned, aromatic iodine, right, inducing the radical species like this. So if you have the alkyl chain that you can make aromatic. You can make aromatic compound too. And then, as I mentioned, Norrish type 1 reaction, for example, aromatic carbonyl, if you have, and due to the Norrish type 1 reaction, you can cut the bond of the alpha carbon. So that gives the aromatic carbonyl radical, and also the alkyl radical too, right? And also you can find a B radical species. You can understand from this figure. So if you have a cyclic molecules, and if somehow you could cut off here by the photoexcitation, photo-induced reaction, at this point, the electrons are given to each other to make the two radical component in a single molecules, which is called a B radical species, right? So as you can see in this figure, right, this is a Norrish type 1 reaction. So meaning the alpha carbon can be cut off here, and then you could see the B radical species. Okay. And also you can find some radical ion species when you have a donor molecule and acceptor molecule. So donor gives the electron to acceptor. So meaning that donor molecule changed into the cation, and also it's a radical species. And also acceptor is a negative ion and radical species. So there's a radical cation and an ion. Yeah, so this is a radical ion species due to electron transfer process.